Algebra Honors Unit 7 is the Polynomials unit. We are looking at day 8. We have a warm-up for factoring trinomials. So it's a lot of questions, but hopefully we can recognize some patterns and get through these pretty quickly. First, the first three ask me to factor out the greatest common factor. So I'm going to pull out whatever I can. I have 2x squared plus 4xy minus 10y squared. The only thing I can pull out is a 2, so I'm left with x squared plus 2xy minus 5y squared. Okay, looking inside there, I don't see anything else I can pull out. 2ab squared minus 5ab minus a squared b cubed. I'm going to pull out a and b, because I just can get an a out of everything and I can get a b out of everything. So ab times 2b minus 5 minus ab squared. All right. Looking here at x squared times x minus 1 minus 2 times x minus 1, I see that I have a matching or common binomial, so I'm going to pull that out. I'm going to say that x squared times x minus 1 divided by x minus 1 is just x squared, minus 2 times x minus 1 divided by x minus 1 is just 2. And so that's my final. I pulled out the greatest common factor. It just happened to be a binomial instead of a monomial this time. Okay. Next, factor the polynomials. So first look for greatest common factor, and then if you can use any of your patterns, we can factor pretty quickly, right? So no common factor here, but x squared plus 8x plus 15. My leading coefficient is 1. So if I can find my magic numbers using the x puzzle, what multiplies to give me 15 but adds to give me 8? That's going to be 3 plus 5. Since my leading coefficient is just 1, I can just dump those straight into binomials, right? X squared plus 5x plus 3x is plus 8x, and then plus 15. X squared plus 6x plus 9, I have a perfect square and a perfect square. If I take the square root of x squared and the square root of 9, I get 3x, and double it, I get 6x. This is a perfect square trinomial. So I'm going to take the square root of the first term and the square root of the last term, and I'm adding them together and squaring them. I'm adding them together because that center term was a positive or added. 3x squared minus 7x minus 6. Well, I don't see any perfect, or I don't see any greatest common factor that I can pull out. So this is going to be a little more complicated, right? Two numbers that multiply to give me negative 18, because that's a times c, but add up to give me negative 7. Let's see, 9 and 2, I think is going to be that. So I'm going to say negative 9 times positive 2 is negative 18, and negative 9 plus 2 is negative 7. You can solve this by grouping, or you can use your box method. I'm going to use box method, but if you do grouping, that's totally fine. Okay, whatever you like. Or if you can kind of do trial and error, you can probably do this one too. Okay, I'm going to put my first term, the whole term, in my box, and my last term in my box. And I'm going to split up that middle term into negative 9x and positive 2x. So if I look down, I'm going to take a 3x. I look down, I'm going to take a 2. Side to side, I get an x, and side to side, I get a negative 3. This just broke up into x minus 3 times 3x plus 2 for me. Double check. X times 3x is 3x squared. Outer is 2x. Inner is negative 9x, so that's going to give me negative 7x. And then last is negative 6. That worked. I checked it out. I just multiplied to make sure it got me back to my original trinomial. Let's factor this trinomial, and I see that everything's divisible by 4, so definitely always look for a greatest common factor. So now I notice I have a perfect square, perfect square. If I take the square roots and multiply them together and double them, it gets me that center. So I know I have a perfect square trinomial. 4 times x is the square root of x squared. 4 square root is 2 rather. And since I'm subtracting in the middle, I need to make my binomial subtraction. Okay, 4 times the quantity x minus 2 squared. That's my answer. If you check your work, you have to do x minus 2 squared first and then multiply that 4 back through. 5x squared plus 13x minus 6. I know a is 5, b is 13, c is negative 6, and a times c is negative 30. I need two numbers that multiply to give me negative 30, but they have to add up together to give me 13. And that is going to be 15 and negative 2. 15 and negative 2. When I multiply them, I get negative 30. 15 minus 2 is 13. I cannot just give myself binomials because I have to figure out what those are. I can do this by grouping or by box. I'll do this one by grouping just because I did the last one by box. So I'm only going to break up my 13x, okay, into my magic numbers. I'll have 5x squared plus 15x minus 2x minus 6. From my first two terms, I can pull out 5x. I have 5x times x plus 3. From my last two terms, I can take out negative 2. I have negative 2 times x plus 3. I see the binomial I want to pull out, so I'm going to have x plus 3 times 5x minus 2. Okay, that should be my answer. X times 5x is 5x squared. Outer is negative 2x, inner is 15x. 15 minus 2 is 13x, positive, there you go. 3 times negative 2 is negative 6, so I checked it and it worked. X squared minus 14x plus 49. I see perfect squares, and I know that the square root of 49 is 7. 7x doubled is 14x. I know I'm going to have the square root of my first term, the square root of my second term, and since my middle term is subtracting, I'm going to subtract here. So that trinomial is a perfect square trinomial. When I factor it, I get x minus 7 squared. Hold on. You can do this other ways as well. You could always use your x puzzle and say what two numbers multiply to give me 49 and add together to give me 14, negative 14 rather. And so you know that's negative 7 and negative 7, right? This would give you x minus 7 times x minus 7, which I can rewrite as x minus 7 squared. So there are always multiple ways to get these guys done. 6x squared plus 9x minus 27, those are all divisible by 3. I have 2x squared plus 3x minus 9. So now I'm probably going to get to do binomials. Let's see. I need two numbers that multiply to give me negative 18, right? 2 times negative 9. And they have to add to give me 3. So 6 times 3 is 18. 6 times negative 3 is negative 18, and 6 minus 3 is positive 3. So I think that's going to be it. Let's say we have, no, I have to do my box. I can't just, what am I doing? I can't just plug in x's. Okay, so I now have my magic numbers. Let's make a box. Let's make a box. So I'm going to put in my first term, 2x squared. Remember, we're doing just the new trinomial. My bottom right is negative 9. I found 6x and negative 3x. So looking down, I get to pull an x. Looking down, I get to pull a 3. Side to side, I'm going to take 2x. Side to side, I'm going to get negative 3. All right, so I think I have x plus 3 times 2x minus 3. I just want to at least double check my binomials that they come back to that trinomial. I get 2x squared. Outer is negative 3x, inner is 6x, so 6 minus 3 is 3, and last is negative 9. I'm pretty sure I got that. 6x cubed plus 24x squared minus 30x. I'm going to take out 6x. I'm left with x squared plus 4x minus 5. Okay, don't lose that first 6x because that's part of the answer. But I need two numbers that multiply to give me negative 5, but they add up to give me 4. And so I think that's going to be 5 times negative 1. So I have 6x on the outside, and I'm breaking up this trinomial into x plus 5 times x minus 1. X times x is x squared. Outer is negative 1x. Inner is 5x, so 5 minus 1 is 4. Last is negative 5. That is it. Okay, so the more you do these, the faster they are for you, and the more you recognize patterns, also the faster you can do these problems. We have two more for this warm-up. This is x squared minus 36. It's a difference, right? And those are both perfect squares. So with a difference of squares, my rule is I'm going to take the square root of the first term and the square root of the last term. I'm going to have x plus 6 times x minus 6. That's because when I multiply those back together again, I'm going to get rid of my middle term. X squared plus 81, I see some perfect squares, but this is not a difference. We can't do anything with that. It's just x squared plus 81 or prime. We can't break that one up, okay? Great, thank you so much for watching, and we'll have notes today on factoring things that have 4 terms.